SQL Server Advanced Data Mining. So far we've used the Business Intelligence Development Studio and the Microsoft Excel add-on to create our data mining structures and models. This is fine, however, sometimes we want to programmatically get things done. In this nugget we'll talk about refining our testing model, and we can do this through DMX. With our DMX statements we can programmatically create the mining structure and any models associated with it. We can then also process our models so we can bring in data that maps onto that mining structure. What's nice about it is that you can process it several times with different data sources if you'd like. And then the last thing we'll talk about are making predictions and analyzing the data. You can use any of the algorithms that Microsoft provides. We're going to be focusing on naive Bayes, as well as clustering and decision trees. Let's get started with creating our mining structure. There's a programmatic interface to tap into our data mining, and you can use these DMX statements to pretty much accomplish anything that you can with the graphical interfaces. So what I'd like you to do is open up your SQL Server Management Studio, and I just want you to say File, Connect Object Explorer. Make sure you connect to your analysis services. Okay, so you'll see under databases, we have several different databases. We're going to create a new database. So we'll start from scratch, and we'll call this Data Mining DMX, and we'll just use the service account. And now we have it down here. So when we expand this, you'll see under mining structures, there's nothing there yet. Our goal here is to use DMX statements to create the mining structure, the models, and then query the information in there. So here's our database. All you need to do is right-click on it and say New Query and choose DMX. You'll see that we have two different windows here. We have metadata, which gives us information, general information about our mining models, and we also have functions that we can use. Now right now it's saying that we have error loading it because we don't have those things defined yet. That's just fine. We'll fix that in just a moment. We will be focusing once again on the bike buyer scenario. So what I'd like to do is first of all use DMX to create a mining structure. Remember, a mining structure just contains a name and the column names as long as the data types and whether it's a continuous or a discrete type of value. So I'm going to say create mining structure, and let's give it a name. I'll call this bike mailing, and then have a parentheses, and let's move this over a little so you can see this better. Here are my different columns. I have customer key, which is a long value. Here it's specifying that it's the unique identifier. We have the age. Look at this, it's long. You would think that it would be a continuous type of value, but since it says discretized, it means that we've just clumped different ages into groups. So we have, for example, 0 through 30 or 31 through 35 and so on. We have bike buyer, which will be 1 or 0, commute distance, gender, house owner flag, and so on. This clause down here that says withhold out 20%, that has to do with the partitioning. So 20% of whatever data we're looking at will be set aside for testing, whereas the other 80% will be for the training. Repeatable 100, this is just an integer that goes in here for a seed value. So if you want the same partitioning to occur over and over again, then use the same seed value. If you want it to be randomized, then just don't even provide this little clause down here. I will go ahead and execute this. My execution was complete. So now if I click on here, connect to my Object Explorer, we can now refresh. Here's our data mining DMX, and here's our mining structure. You can expand that. Mining models is still empty. We haven't created any models. Okay, so let's talk about creating a mining model. Oh, and by the way, just for your reference, if you ever want to drop the mining structure, all you need to do is say drop mining structure and you give the name. That will delete any of the corresponding mining models as well. Okay, so let's go on to creating our mining model. The easiest way to do that is with an alter statement on your mining structure. So I'm just going to issue this statement down here. I'll say alter mining structure, and then I give the name. And we're going to add mining model, and let's give this a name. We're going to be creating a naive Bayes model, which is typically used to look at the associations between different attributes. Okay, so let's call this naive Bayes, and maybe we want to apply a filter to it that just looks at the men. So we'll call this naive Bayes men. And then we put a parentheses in here, and we specify which columns we're interested in. Now, if you don't specify any columns, it's going to default to the structure of your mining structure right there. But be careful with naive Bayes because it doesn't like continuous values. So we would actually get an error if we just stuck with the default because it would get angry at this little column right there. Okay, so notice that we're omitting the yearly income. So then we have to specify which type of model we're using. So we'll say using Microsoft naive Bayes. And then we can even put a filter in here. You actually have to say with filter, and then parentheses, gender equals M. Okay, so now we can go ahead and highlight that and execute it. It was successful. We can now click on this just like we did before and then hit refresh. When we drill down to this now, you'll see that under mining structures we have our naive Bayes men that we created. Once again, if you want to drop this object, this mining model, you would simply say drop mining model and you give the name. Okay, so we have that one mining model. Oftentimes you'll have multiple mining models. So let's do the same kind of syntax. We'll say alter mining structure, and it is bike mailing. And we're going to add a mining model. We're going to call this bike mailing decision tree. And then we put in parentheses the columns that we want to include in there. So notice here that I have my bike buyer and the keyword predict next to it. So that is the prediction column that we're focusing on. Then we specify what type of model we're using here. So make sure you close off the parentheses and you'll say using Microsoft decision trees. And you can even specify that you want to enable drill through. Okay, so now that you have this, let's go ahead and execute it. And now we can connect once again and refresh, and you'll see that it appears down here in just a moment. Under mining models, we now have the bike mailing decision tree. If you wanted to drop that model, you'd say drop mining model, bike mailing decision tree. It's that easy. Let's add yet another one dealing with clustering. So we'll say alter mining structure, bike mailing, add mining model, and then we give the name. So I'll call this bike mailing clustering. We specify what we're using as far as the mining model type. So I'll say using Microsoft clustering. And then let's also enable drill through. Now notice in this example I didn't explicitly state the columns, therefore it's going to default to the mining structure columns. Highlight it and execute it. Looks successful. I'll go ahead and reconnect there and then hit refresh. And here is our clustering. There's a really cool thing that you can do, and that is creating one mining model that derives on another one. For example, if we want to use this bike mailing clustering as a base model and then create another one on top of it, here's the syntax. We would say select star into and then the name of the new model that we want to create. So here I'm going to call mine bike clustering 3 using, once again, Microsoft clustering, and we might say here that our cluster count is equal to 3. The default cluster count is 10, and so you can override that setting there. From, and this is the key clause here, bike mailing clustering. In other words, create this new model that's based on this original model right here. So once we issue that statement, we can then refresh and there it is, bike clustering 3. Now we have the mining structure, but we haven't processed any data through there. It doesn't know of any data yet. And so what we would like to do is feed it some data so we have some training material. And that's where we can say insert into mining structure. And it's bike mailing. And in parentheses here, the columns that we're populating. And what I'm going to do is tap into an underlying database to populate it. Okay, so this is our training data. We're going to say open query, in parentheses, the name of our database, and then our select statement. So you'll see here that for the most part, these columns in this example map nicely onto these, but not all of them. For example, here, number of children at home is all squished together. It's not the same as this right here. Okay, so the columns are not always going to be identical. However, the number of things that you're selecting and the number up here should match, as well as the data types. Okay, so we're grabbing our information from dbo.targetmail. Looking at our statement here, you'll see that we're making the assumption that we've got a data source called AdventureWorks DW 2008. Well, if you look at your data sources right here, you'll see that that doesn't actually exist. So to create that, the easiest way is to go into your Business Intelligence Development Studio, and from here you can say File, Open, Project or Solution, and then there's your Data Mining DMX. And under Data Sources, you can then right-click on here and say New Data Source. Okay, so your data source right here, yours is going to be a different server name, of course. And we'll just use the service account. And there it is. Make sure that it matches up with the name in your statement. So AdventureWorks DW 2008. I'm going to hit Finish. And now I can save all and then move this out of the way. At this point, we can then highlight the statement right here and execute it. Now you'll see that it's executing the query and it is taking several seconds. This can actually take several minutes depending on how much data you're processing. And now it said it successfully executed. At this point, we can issue select statements on the processed models. So here we might do something like select star from, and we'll say mining structure, and we'll call this bike mailing, because because that's the name of it, dot cases. So that's all of the training cases. So here we can now issue this statement, and we'll see the actual records. You might need to move this window up a little bit. Here we have it. We have the customer key, age, whether or not they're a bike buyer, and so on. And you can even narrow these down with the where clause. For example, here you'll see that some of these are bike buyers, some of them are not. If you're only interested in the bike buyers, then you can say where bike buyer equals 1. Now let's take a look at this. There's our data. You'll see it's 1 across the board. You can even put an and on here. For example, you can say if bike buyer equals 1 and gender equals M. So that's the way you drill down to the cases in your structure. And by the way, for this to work, you do need to have drill down enabled for your mining structure. You can even query the models themselves. Okay, for example, if I want to query the clustered model, I can do a select star from, and if you want to either type it in or drag it over, you can. For example, here I've got my clustering 3 right here. I can just drag this over here. Make sure you put that in brackets because there are spaces in there. And then you can say dot content. So this gives us meta information about the mining model. Okay, so here we have the catalog name, the node name. Remember, we have several nodes. See how I have nodes 1, 2, and 3? We have the node type, the caption for it, and so on. The one that I find rather interesting is under node distribution. You can expand any of these. So for node number 1, I can click on that. And if you expand this a little bit, you can see the attribute. For example, if the age is less than 41, then the probability that the person is a bike purchaser is 23.5%. You can also issue a very similar statement dealing with our decision tree. So I'm just going to copy and paste here. And instead of saying bike clustering 3, I'm going to drag over the bike mailing decision tree, insert it right there, and then execute it. Okay. If you want to see the distinct values for particular attributes, you can do that as well. For example, I might say select distinct region from bike mailing decision tree. Get rid of the dot content. So we have Pacific, North America, and Europe. You can even perform predictions, and what that entails is joining the model with some kind of hypothetical values. For example, if you take a look at this statement right here, we are selecting, notice that we're selecting from two different things. We have this natural prediction join right here. The information down here in parentheses is just hypothetical information that I'm proposing. For example, I'm saying, you know what, if somebody is 35 years old and their commute distance is between 1 and 2 miles, and yes, they own a house, and they don't own any cars, and they have no children, what is the probability that they're going to purchase a bike? Okay, so all this information here is just a what if. Okay, so as far as the select information right in here, what we're doing is just, this is going to print out 1 for bike buyer or 0 for not a bike buyer. The predict histogram is going to give us some statistical information, and then we can use the predict function passing in bike buyer, and then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can use the predict histogram to get the histogram. And then we can to say whether or not they would purchase a bike. Okay, so let me show you what the results look like on here, and then I'll show you where you can find some more functions to help you out. You'll see here that the person is most likely, yes, going to purchase a bike. Okay, so if you expand statistics, it's basically saying, you can expand this as well, that the probability is 76% that this person is going to purchase a bike, 23.5% that they're not going to purchase a bike. Now you can kind of do the same thing but in batch format. For example, if you want to see some of the testing data and look at the probability for a bunch of records, you can do a query that kind of looks like this. Let's start at the top here. Here we have a select statement, and you'll see we have x.star. X is our table alias that we've defined right down here. You'll see we have this open query, and we're selecting from our data source right here, AdventureWorks DW 2008, and you'll see how we're grabbing this information from the prospective buyer table. Okay, so our table alias once again is X, and you'll see that that query has a prediction join on our model, the bike mailing decision tree model. So we're grabbing x.star, in other words, all the columns in there. We're also grabbing the model's bike buyer column, as well as the probability that somebody's going to be a bike buyer. And let's scroll down a little bit further. This on clause is just performing a join on the different conditions. So you'll see on the right hand side we have x dot and then the column names, and on the left hand side is the decision tree model columns. Notice also that our where clause is saying where the bike buyer is equal to 1, because all we're interested in are the people who purchased a bike. And then we're going to do an order by predict probability. So we have some kind of ordering, and it's going to be in descending order. So our result set, we're going to have a bunch of records in there, and the first record in there will be the person who's most likely to purchase a bike. Now if you want to execute this, just highlight this, and let's execute it right now. And here we have the names here. Let's scroll over to where we see the probability. So here's the probability right here, 63% probability that this person will purchase a bike. Now it's important to understand when you scroll down here that in our on clause we're only joining the marital status, gender, house owner flag, and number of cars owned. There's other columns as well in this data, but those are the only attributes that we're taking into account. We're going to get different results if we comment out, for example, number of cars owned. Now you'll see that we have lots of records in this output. What we can do is to narrow it down. Maybe we're just interested in the top 10 people who are likely to purchase a bike. So we can say select top 10, and then the rest of the query is the same. Here are our records. Let's review what we learned in this nugget. We were focusing on DMX statements to programmatically accomplish mining tasks. We could create our mining structure using the create mining structure statement, as well as altering the structure to create various models. Remember, you can make multiple models that adhere to a mining structure, and you can choose a subset of the structure columns with those models. You can also refine your testing model. So remember, we had a clustering model, and then we created a model that was based on that original clustering model. So you can make modifications to it. We use the insert into mining structure statement to process the data for our structure and models, and then we analyzed our models programmatically as well as looked at the predictions. Remember, with the predictions, you can specify just a scalar prediction. For example, if you want to specify if somebody is a certain age, a certain yearly income, and region that they live in, you can determine whether or not they're going to be a bike purchaser, or you can do this in batch mode. So you can look at a bunch of different records and determine which one of those records has the highest probability of making that purchase. Well, I hope this has been informative, and I'd like to thank you for viewing.